So, you are using tools like Claude and Gemini to code, right? It feels like the future. Until the code it spits out is just wrong. It's generic. It doesn't know your architecture. It ignores your patterns. It writes massive code, and you spend more time fixing its help than it would have taken to write it yourself. It's frustrating. Today we are fixing that. We are talking about an important file you can create for AI assisted development, the context file. Before we get started, make sure to subscribe to this channel and click the alert button. That way, when I release more videos and more tips like this, you will get notified. If you are excited to diving deeper into the world of modern software engineering from architecture to cloud and security, check out my video courses where I explore these concepts further and tackle real-world challenges. The link to the courses is in the video description below. And here is a bonus. Subscribe to my newsletter and you will get free and discount access to my video courses. My Claude.md strategy for turning Claude code into a real pair programmer. What is a context file? You've probably seen this floating around. I'll call mine Claude.md. This file is where you tell the AI how to behave, what your standards are, and how your specific project is built. And here is a tip. You don't want one giant 5,000 line file. You split your context. You split it into a shared file that lives in a shared spot and contains all your general AI coding guidelines. There you can put your definition of done, how you handle security, or your testing philosophy. And the next one is a project-specific file. This file lives in the root of the project you are working on. It contains project-specific architecture, patterns, and workflows. When you combine those two, you are not just prompting, you are context engineering. You are giving the AI the vibe of the project. Okay, theory is over. Let's see a real one. I'm about to walk you through a sample Claude.md file. It contains a lot of instructions and restrictions to guide Claude code. First, we have this sentence about our project context. This is an LLM app using Python, LangChain, LangGraph. As constraint, use data in memory for cache, storage, and queue. As code standards, we want max 50 lines per function. Use descriptive variable names. Use the latest stable versions of all libraries. Follow good practices and design patterns. And we want to avoid excessive logging, no generic error handling, no to-do fix-me commands, no function with over 5 parameters. We don't want redundant code, no magic numbers, no unvalidated inputs, no inefficient algorithm, no copy-paste code blocks, no sequential awaits, no unstable code. If you are planning to generate some mermaid diagrams, you need such a section. As best practices, you can keep diagrams focused, use consistent visual semantics, always include legends, avoid redundancy, progressive disclosures, clear flow direction, purpose-specific diagrams. We wanted also to make the code review-friendly with small atomic changes, break large features into multiple small PR, max 200 lines, clear context, always explain why the change is needed, not just what changed it, self-documenting code, complete implementation, test coverage with meaning. Tests must validate behavior, not just increase coverage metrics. We want also security-first development. That's why we have instructions like use only approved libraries, no experimental patterns, security validation, compliance check, never bypass security. Don't disable linters, skip tests, or ignore security warnings. We used also incremental development rules like start minimal, iterate with purpose. No big bang commits, avoid massive single commits that change everything. We want progressive enhancement, maintain working state. We had also things like performance consideration by optimizing for readability first, clear code over clever code. We wanted profile before optimizing, don't guess about performance bottlenecks, consider scale, resource management, always close connections, clear timeouts, free resources, batch operations, Use bulk operations for database API calls when possible. As testing standards, we have here test behavior, not implementation, because tests should survive refactoring. We have things like fast feedback. Unit tests should run in milliseconds, not seconds. Code review mindset, write for the reviewer, assume the reviewer has no context. Self-review first, review your own code before submitting, explain non-obvious decisions, consider future maintainer, address feedback constructively. All review commands deserve thoughtful responses. You can see we have more rules here. Never generate entire features in one response, break into logical chunks, never code without understanding existing patterns. We don't want tests that only increase coverage metrics. We don't want complex abstractions for simple problems. We don't want code that bypasses existing validation security. We don't want the AI to be verbose and generate duplicated code. We want Claude Code to generate code that matches existing style guides. That's why it's very important for a team to define their style guides. We want comprehensive error handling, meaningful variable function names, tests that validate actual behavior, documentation for public API, production-ready and PR-ready code that is easy to review and understand by human. And before our AI tool generate code, we wanted to analyze existing code-based patterns, understand the full context of the change, consider security implication, think about maintenance burden, evaluate if simpler solution exists, and we wanted to focus on quality metrics like review time ideally should be under 30 minutes per PR, review iterations under 3 rounds, change failure rates under 5%, time to production under 1 day for small changes. And for post-deployment issues, we want 0 issue for standard features. We have here also a block about definition of done. Claude follows project style guide. All tests pass locally. New tests should cover new functionality. Error scenarios handled gracefully. Performance impact assessed. Security implications reviewed. Documentation updated if needed. Code self-reviewed before submission, and PR description explains the why. Breaking changes clearly marked. And that's it. That simple file just established your project's technical standard. But the real power comes from the next section. Your rules are probably bad. Now, your file might be full of blunt dogmatic rules that just get in the way. Rules like no function over 50 lines. What happens when you need 80 lines? The point of a rule like max 50 lines isn't to be an absolute law. It's a guardrail. It's there to force you or the AI to pause and justify why 80 lines is the right call, rather than just letting complexity creep in until you have 500-line function or over 1,000-line classes or services. Here is how you can refine the blunt rules. Instead of no dict of string and any, try this. Use typed dict or pedantic models for our domain objects. A dict of string and any is totally acceptable for initial JSON parsing from an external library, but it must be converted to a model before it touches our business logic. See? Context. Instead of no functions with over 5 parameters, try this. If you find yourself needing more than 4 or 5 parameters, consider if they form a cohesive group. If so, bundle them into a data class or a setting object. Instead of no inefficient algorithms, try this. Choose the right complexity for the data scale. A no of n square algorithm is fine for 100 items. If you are doing it on 10 million, you must justify it in a comment. Instead of no untestable code, try this. Design for testability, document constraints if not feasible. The main idea isn't to hamstering the AI, but to have guidelines with exceptions. Cut anything Elinta could catch. In short, the goal is to give the AI a framework for sound engineering judgment, not a list of hard no's Elinta could handle. Final thought. That file is the difference between fighting your AI and having it actually feel like a teammate. By giving the AI these guidelines, you are turning it from a generic code generator into a real pair programmer that actually understand your project's vibe. You spend less time fixing its mistakes and more time thinking about the big picture, which is, after all, our job. So stop yelling at AI for being dumb. Go write your context file.